Hello, this is a tutorial on how to export a Linux directory using Samba server and how to use it from another Linux computer. So we have two computers. The left one is a server named A server, has IPv4 address ending with 202. Right computer is the SMB Samba client, Kubuntu 2604 is the name of the computer, and IPv4 ends with 92. I have written things down because otherwise things are going to get very complicated pretty soon. So they're similar machines, they're virtual machines using Virt Manager QEMU, Kubuntu 2604 installed on both. I have the OpenSSH server installed on both, and also I can connect using the remote desktop protocol to both. So let's connect to these two computers and see, first of all, if the two computers can communicate with each other, if they're in the same local area network, if they can see each other. So the left one will be the server. Let's connect. The computers have different user names and different passwords. I have connected using the remote desktop protocol in graphical user interface mode to the server. Let's confirm again, 202. And then let's connect to the SMB Samba client. Let's see if networking in general works. Works on the server. Works on the client. Let's see if the computers can ping each other. So from the client, we want to ping the server. And it works. From the server, I want to ping the client. It works. Often when I expose a Linux directory as a Samba share, that means that that share will be available for many months. And in this case, I will want to make sure that the IPv4 address of the server stays unchanged. So the Linux computer that's serving Samba shares, SMB shares, is going to become a server, is going to stop using a DHCP client and start having a fixed IPv4 address. In this case, we're not going to actually do that because we're just creating a share for a number of days. But if you want to make sure that the Linux server has a fixed address, there are multiple ways of doing it. One of the simplest ones is to configure Network Manager such that the IPv4 address of the network interface card doesn't use a DHCP client for getting an IPv4 address, but actually has a fixed IPv4 address. Let's see how we do that. In System Settings, KDE Plasma, we go to the connection. In this case, it's a virtual machine, has a network interface card of type VirtIO. I have selected it. It's a wired connection. And then in IPv4 tab, I'm going to make sure that we're not using DHCP, or maybe, yeah, no, make everything manual in this case. So as the DNS servers, you can use the already configured DNS server, or you might choose one of the most widely known DNS servers, for instance, the ones from Google. Let's see if it just works. So 8.8.8.8 is one of the top two most important publicly usable DNS servers from Google. The other one is 8.8.4.4. And then we're going to want to provide an IPv4 address. We can keep the one that existed previously, which is the one ending with 202. Let's see if copy paste actually works. Nope. Let's see if copying from here works. Okay, net mask is the default one, so 255.255.255.0, and gateway, I don't actually know. How do we compute the gateway? Probably the IPv4 address in the same block ending with .1 in this case. Okay, asks for sudo powers on the server. We can actually change this IPv4 address to something else to actually make sure everything has just worked. I'm not sure how well this thing actually works in practice if there's many layers that might go wrong in here. A simpler approach would be to either apt purge network manager and stop using it and just use the Ubuntu default networking technology, which is NetPlan. Or you could use Debian style networking, or you could use systemd style networking. Let's prove that things started to work, or the IPv4 address has already changed correctly. How do we do that? So IP and then A should end with IPv4 address 202, so the change has not applied yet. Again, I'm not sure exactly how to convince Network Manager to instantly apply the settings or to actually apply the settings perfectly. I have had all sorts of encounters with these many layers of networking when I have a computer that's actually a server and that's always on, and then that should always have the same IPv4 address. So let's remove everything, and I'm going to actually reboot the computer and see if the settings have not changed. If this is a virtual machine, I should have actually created a virtual machine snapshot before playing with Network Manager. That's how problematic has been to me for Linux server computers. Okay, theoretically I have applied. Let's reboot the computer. I have restarted the server computer. Hopefully the IPv4 address is configured correctly and it will stay the same for a while. So the one ending with 202 as we have in the text file. Next up, we're going to create a directory on the server computer, put some files in there, and then install the SMB server Samba and expose that directory as a SMB CIFS Samba Windows share. On Google, I have searched Ubuntu 26.04 how to share a directory using Samba, and I got to the result from Linux config, how to set up Samba file sharing on Ubuntu 26.04. And I'm not sure if the instructions are perfectly correct, but they sound correct. So let's follow this tutorial first. On the server, we want to install the SMB Samba server. So SMB CIFS is the Windows protocol for sharing directories, but not only, also printers and remote registry and the remote server configuration and other services available. And this has improved and worked in Windows 95, in Windows 3.11 for workgroups, if I remember correctly. So it's a protocol that has evolved along as time went by, and the open source implementation is the Samba project. Let's become super user on the server. It says that we should install the Samba server, but also the Samba client, because we want to test first from the server. So we should enable the SMB share on the server, but then also test from the server that the share works correctly. Let's just copy paste these things if copy paste works. Update, make sure we're up to date on both machines. I have also installed all of the missing updates. So that was update and then upgrade. We installed the two packages, Samba the server and SMB client. We can see two systemd services, SMB and NMB. And we can see the default firewall on Ubuntu 26.04, which is UFW. Let's first see the status of the firewall. So says that the firewall is inactive, which is correct. We're on just one hardware computer and we're running two virtual machines. There's no security implications if the firewall is disabled on the virtual machine where we have the Samba server. If you actually have this computer exposed on the internet, which is a bad idea, why would you expose a server that has Samba shares and expose it on the internet? Why would this computer have a real IPv4 address, one that's pingable from the internet? But that's a totally different discussion. Let's configure SMB and forget about the firewall for now. Okay, so we have both systemd services which we can look at the configurations of if the server has started. Systemctl status for both, so SMB. SMBD, okay. NetBIOS is yes. So we have a service for legacy NetBIOS name resolution. I have not great encounters with NetBIOS name resolutions. That's why I always suggest fixed IPv4 addresses for the Samba share server. Let's see what SMBD ---- version says. Next up, we're going to create a directory. We're going to create it in the directory of my user. So who am I? The username is sadmin. Okay. This is a default home directory. Let's create a share. SMB share. I'm going to put 3 files in there. So I have put the content of the instructions file in a text file, and then I have created a screenshot of the desktop. So we have 2 files in the directory tilde/smb share, and we want to expose this one to users that know the user and password of this user, which is named as admin. So now that we have the directory, we can try to connect to create the SMB Samba server configuration. Let's find it in the /etc/samba directory. Let's become super user. Go to etc samba. There's the configuration file smb.conf. Let's make a backup of this thing. And now we can edit the configuration file. So this is a configuration file in /etc/samba named smb.conf owned by the user root. So in order to edit it, I have opened a terminal emulator. I have become the root user using sudo space su. And then I'm editing the file in text user interface mode using the nano editor. So I'm not doing any graphical user interface text editor with interesting flow to edit a root-owned file. I'm doing it very basic from the terminal. So by default, there's a Windows workgroup named workgroup, all uppercase. There's no NetBIOS, which is a good idea. Probably listens on all network interface cards. I'm not sure what these things are. And says at the bottom of the file, I should add the definitions for the shares. So there's a chapter in here in this file which is called share definition. We can see that there's ways of sharing the home directories of all users, which is something that sometime you might want. You can share printers. Samba also has support for the Active Directory server, Active Directory domain controller, the directory protocol, probably also a LDAP server. Okay, and we're at the end of the file. So it says that the configuration that we should add to this file looks like this. Let's actually edit it. Okay, the path should be the full path. So let's get there. So what is the path? The name is sadmin and then smb share. So I prefer to edit in a graphical user interface text editor because that's easier for me. And then I'm just going to paste the new block of configuration into the existing file in nano. Linux smb share as comment. Browsable, yes. Read write, so not read only. It's going to require a user and password. I'm not sure what this to do. And then just one valid user, of course, which is sadmin. Let's confirm once more. So the username is sadmin, the path is /home/sadmin/smb share, and this should be it. Right click and paste. Make sure we have a trailing new line, Ctrl X to exit, and then asks if I want to save, Y, and then enter. And then it says that because we have edited /etc/sambla/smb.conf, there's a command line that can verify that this configuration file is correct. Linux config private, yeah, that's not okay. I'm going to edit the configuration file. Page down a couple of times. And then this should be Linux SMB share. So Linux SMB share, the same comment, Linux SMB share. And Ctrl X, Y, enter. Test parm again. And it looks okay. Next up, from the exact same computer, we're going to make sure that the SMB server is using the new configurations. So that systemctl restart SMBD, or maybe just restart the entire computer. Let's see if this is enough. And then it says that on your Linux computer, we have a list of Linux users. In this case, the user is the user sadmin, but the Samba server has a different list of users. So we need a bit of synchronization between the Linux users and the Samba users. We don't need to add any Linux user. It's already configured correctly. And then we need to set to make sure that this user, sadmin, also exists on the Samba database. So still as the user root, and then the name of the user is sadmin. Asks for the password. I'm going to use exactly the same password both for the Linux user sadmin and for the Samba user sadmin. Okay. Enable the user in the Samba database. Not sure if this is actually required, but let's do it. Again, it's always safer to just restart the computer when you do fundamental changes. Copy and then paste. So SMB password -a sadmin to set up to create the user in the Samba database and set its password, and then SMB password -e sadmin to enable the user. Okay, then we can look at the database of Samba users. And it's there. We don't do any UFW configuration. It's disabled by default, and that's a good configuration for our case. and then says that we can immediately test the Samba server using the Samba client. So let's prepare this command. SMB client / localhost should work, yes. And then the name of the share, which I'm not sure which it is. Maybe this one, the name of the group of settings, Linux_SMB share. And we do want to specify the user because we're running as user root right now. So that's sadmin. Yeah, let's not be the user root any longer. Control D. Okay, so the username is known. It's sadmin. The Windows style domain is known. It's the Windows style workgroup named workgroup, all uppercase. But the password is not known for SMB client. And this should be the Samba password, not the Linux password. Okay. And then we have a connection where we can type ls. And we see the two files, instructions.txt, and then the screenshot. Okay, so with this, the Samba server is configured correctly. We should move to the Samba client computer. Different user named administrator. Different password. And in here, I want to actually use the safest, simplest, fastest technology, which is using /etc/fstab with the Linux kernel module CIFS for the SMB Samba file system type. So let's see how we do that. So we need to be the user root. We need to install a package named CIFS utils, which is required for the /etc/fstab line to work correctly for the CIFS file system. And then let's see if the directory media exists. It exists, and in there I'm going to create a directory. So the directory will be /media/computer name and then underscore share name. So this is the server. Make sure I'm not using special characters, dots, spaces, etc. And I'm using underscore instead. So make dir -p and then paste. Okay. And then We can test first from the command line, as in this example. Let's actually do this. How do we copy? But then we'll put the configuration for the Samba share to use in /etc/fstab on the Linux client computer. Okay, so IPv4 address is this one. The share name is this one. The directory is this one. And the username is the one from this server. And since we're running this command from the terminal, it's going to ask for the password of the user as admin. So on the client computer, paste, we're already the user root. Asks for the password. Again, the Samba password of the user as admin. And probably everything has worked correctly. Let's confirm that. And go to the directory. And there you have it. Let's see if copy paste works bidirectionally. We'll create a new file, which we can't. Let's see if we can read the file. Okay, so let's guess why we can't access this share, because we didn't specify anywhere the name of the Linux user administrator on this computer. So this command line knows about the local root user, knows about the remote sadmin user, doesn't know anything about the local administrator user. I have unmounted the directory, so on umount /media and then the name of the directory. And then I have run the command line again, mount -t CIFS, but then with this addition, where I tell it that the user ID for the files in this directory, so the owner user, not the owner group, should be set to the local Linux user administrator. I have enhanced this command with this part. And now in Dolphin, I can both see the contents of the files, which I could previously. I can create new files. I can edit new files. I can create directories. And that's about it. I have full control. This is how the ownership looks like. So ls-la for the current directory says that all of the files and directories have the user administrator, with exception of the parent directory. So /media/192 underscore etc. is still owned by the user root. There's the directory where we mount the CIFS file system. the group of the files and directories is still root. If you want, you can change that in the exact same way, not using UID, but using GID. Let's see if that's the case. So we'll need to umount. Let's close the terminal. How do we do that? I don't know. Control D. Cool. Umount, and then mount using this command line. And then Dolphin complains that there's no directory /media/192, which for a while did not exist. So I'm not sure if this is an issue or something. Meanwhile, the directory has appeared again. The yellow bar did not disappear. Let's look at the configuration again. And it's what we expect. Files directories have user administrator, have group administrator, and then there's others. And the chmod bits are as you would expect. So these first three are for the user, which is administrator. The next three are for the group, which is administrator, and then these are for others. Next up, what we don't like is the fact that we need to specify the password interactively. We want to put a similar line in /etc/fstab, but that will run when there's no user interaction possible. So for that, we're going to use a credentials file, which is going to be stored in the current directory. So let's create it. So in the current directory, we're going to use the graphical user interface text editor this time, and we're going to create a file named /.smb credentials. So hidden file /.smb credentials with just two lines, username and password. Okay, as username it's sadmin. And then I'm going to put the password of the user sadmin in here and save the configuration file. The change to the configuration file should be this one. So instead of specifying just the user, we're going to specify both user and password for the Samba client. But this will stay in a plain text file that's not encrypted. So /home/administrator/smb credentials. Let's do what we did before. So unmount, umount. Why is the target busy? Control D. So don't have terminals open in the directory if you want to umount the share. And then run the command. This time should not ask for the Samba user's password. And everything works as expected. Next up, we're going to edit the /etc/fstab file. So I have prepared a line for the /etc/fstab file, which respects the columns in that file. So source, and then destination, and then file system, and then options for the file system, and then the final two columns. So I have converted the command line mount space -t CIFS in a /etc/fs tab. So we still have the file system, we'll still have the source, we still have the destination, we still have the options for the file system. Let's umount. Let's edit the configuration file. So that's nano /etc/fs tab. I am the user root already. At the very end of the file, paste the line. Trailing new line, just once. Control X, Y, enter. Let's actually put on the screen. So get the content of the file and see if we paste it correctly because of the line break. Everything looks okay. What I did is I have specified that this share, this mount, should not be mounted automatically. So if I restart my computer, this mount will stop existing until I manually decide that I want this mount. Why do I do this? Because SMB servers might be down, the DHCP IPv4 address of the server might have changed. Any sort of things might happen to SMB servers and to SMB shares. When I actually need the share, I'm going to manually mount it. Otherwise, nothing is going to be mounted, no Samba share is going to be mounted because I want the computer to start fast. I want the computer to not have boot failures because a Samba share is not responsive or is extremely slow or is filtered or anything like this. And then also my user interface session should start fast and my graphical user interface apps should work correctly. Theoretically, everything right now is configured correctly. The only thing that is missing is for me to mount. Let's see if Dolphin sees the directory. It doesn't see the directory, which is correct. Let's mount. Let's actually not be the user root for this thing. So sudo and then mount and then the full path to the directory where the CIFS file system should be mounted. Asks for the user of the local user administrator for sudo purposes. And it says that either do systemctl daemon reload or maybe restarting the computer. I'm not sure if we should do this, but let's do it. So again, we have added a line in FS tab, but it's no auto. It says that the folder is empty. I have restarted the client computer, just in case. And let's see if everything just works. And it does. I'm not sure what was that glitch when I have told systems D to reload the configurations. And that's it. That's what I know about having two Linux computers, and then from one Linux computer creating a directory, exposing it as a Samba SMB CIFS share, Windows share, and then on the second Linux computer using that Samba share. It's probably the best way to share files between Linux computers. It's fast, is native, has a built-in upstream Linux kernel module. Samba is very old and well-known open source free software project. The performance is great. What's not such a best fit here is that there's a bit of impedance mismatch between ext4, which is the default file system that I use in Ubuntu 26.04 in Linux in general, and the NTFS file system. In the sense that there's chmod bits on the Linux side, there's no such things, there's standard DOS attributes on the Windows side, there's ACLs on the Windows side, there's something else on the Windows side. The executables in Linux are executables because they have a chmod bit set, whereas in Windows, all files with extensions present in the path X environment variable are executable, such as files with extension .exe, .bat, etc. It's not the most native way of sharing files between two Linux computers, but it's a way that works. And if you have Windows computers on the same local area network, then there's big chances that you're using Samba SMB CIFS already. Thank you.